Thank you, everyone. And more importantly, thank you for staying. I know this is the very last session of the day. So, as mentioned, you can call me Zihon. I'm a solutions architect based here in Singapore in the Google office. And today I'll be talking to you about site reliability engineering. So I'm going to be mentioning this phrase a lot of times during this presentation, so I'll just call it as SRE for short. Before I begin proper, can I just get a show of hands as to how many of you folks have heard of the phrase SRE, or Site Reliability Engineering? Cool, quite a bit. How about DevOps? All right, great. So, whether a hand was up or not, I hope that everyone gets to take away something out of this presentation at the end of this. So, this is like a cloud summit, talking about cloud, and let's talk about what worries us about reliability when we go to the cloud. So, some main concerns come to mind, right? Things might behave differently in the cloud as compared to our on-premise environment. You might also be worried about how to scale your operations team as the service grows. And these are very valid concerns for enterprises or companies thinking about moving to the cloud, either going full native or adopting a hybrid architecture. And we are going to look at SRE and discuss about 5 key areas today in which we can help us manage that transition. First, we'll talk about the core problem that SRE solves and the high-level organizational structures that facilitate the practice of SRE within your organization. Second, we'll talk about the key principles that SREs believe in, that SREs use to keep systems appropriately reliable. Third, we'll talk about the key areas and responsibilities that SRE teams have. Next, we'll summarize the essentials of SRE and discuss how you can begin to adopt SRE within your organization. Finally, we'll talk briefly about the different ways that Google can help you achieve your reliability goals with SRE. So let's start by talking about the core problem that SRE is really trying to solve and the structures that facilitate the practice of SRE. We need to talk about the operational cost of software. So software engineering traditionally over the years has typically focused on designing and building stuff, but not so much on operating it. Even though running the software once it's launched, it's far more expensive, often up to 10 times the cost of developing it. In our experience, organizations often focus on hiring great software developers, but not so much about operations. It's often seen as someone else's problem. So this leads us to this situation where the incentives aren't aligned. Developers like to build new features, build them quickly, build them fast, then they throw them over the proverbial wall to the operations team, and then move on to the next big thing. Meanwhile, the operators juggle everything being thrown at them, while also being responsible for things like scalability, reliability, as well as the maintenance of the software. This is a very common situation that we have nowadays, right? In other words, developers want to go as fast as they can, whereas operators are looking to slow things down as much as they can in order to reduce risk. It's a pretty terrible setup. It's not designed for harmony within the organization. It's brittle and it doesn't scale well. And it establishes organizational silos. So there are some techniques for dealing with this that have come up over the years. So there used to be a wall between what we know as product management and product development. And that's where the agile methodology was developed around this to solve that problem to a certain extent. DevOps also came along roughly at the same time as SRE and said that, look, you need to resolve the tension between development and operations as well to achieve better reliability and agility. It's through the entire supply chain. It's not just about business and development. You have to think about development and operations too. So I'll be using sort of a Java analogy a little bit from now on. So let's break down DevOps. There are many definitions of DevOps. here's our definition, our take on it. DevOps is a set of practices and guidelines that say, look, here's how you're going to break down these organizational silos. So there are 5 key areas in this. First, it tells you that you need to break down that wall between development and operations to help with collaboration and velocity. Next, we know that things are going to break, and we plan for that and accept failure as a normal part of day-to-day life. Smaller changes are also easier to implement and deploy, which also makes them easier to roll back, which helps with MTTR. We also want to remove human error from the equation as much as possible, and we do this through extensive tooling and automation. Finally, we want to measure everything. We want to measure everything because measurement is critical to achieving and evaluating success, especially in the above 4 areas. You need to know quantitatively how well you're doing and not just go by your gut feel or instinct. We'll return to this throughout the presentation and track how SRE implements these practices. So a key tenet of the SRE approach to operations is that we need to use data to guide our decisions. And we need to treat operations as a software engineering problem. For that to happen, we need people with software engineering skills who have the ability and motivation to automate away operations. And we need to design our systems to be reliable and operable from the start, rather than trying to bolt it on, retrofitting it after the fact. In a nutshell, here's what SRE teams do. They write software and design systems to operate scalably, reliably, and efficiently. And SRE teams achieve that with a combination of 3 things: a group of people, a set of philosophies and mindsets, and also a set of engineering practices and tooling. So SRE requires all 3 of these. So given the definition of DevOps as a culture and practice aimed at breaking down silos between various teams, we can see what is the relationship between SRE and DevOps now. They are not competing philosophies. Rather, SRE, you can think of it as an actual concrete class that implements the principles of DevOps. So at its core, SRE has just one principle, and we call this error budgets. To talk about error budgets, we first have to talk about reliability, and specifically, how do we measure reliability? Traditionally, the simple and somewhat naive way to do this has been by measuring how much time things were good overall in the measurement window. This is a very nice idea. It's intuitive to understand, and also fairly easy to measure for things that are continuous and binary. For example, if you have one web server, it's very easy to measure reliability. It's simply about whether the web server is it up or is it down. For more distributed and complex systems, especially the ones that we run nowadays, you need fancier definitions of reliability that can also handle whether your service is partially up, as well as measure the quality of service that's being delivered. But the basic requirement remains the same: a definition for reliability and a way to measure it. So then the next step is to have what we call a reliability goal, a certain amount of reliability that we are trying to reach. Now, you've probably heard of a 3 nines or 4 nines or 5 nines, etc. service. What this really boils down to is that it's about the amount of downtime you're willing to tolerate in our service. But remember, in a modern, complex, distributed system, it's rarely about being in a hard down state. These numbers assume 100% outage. But usually there's a lot more nuance and room to maneuver if you can measure brownouts and not treat them as 100% errors or 0% errors. So you might be thinking that there's a number missing from this chart, and that's 100%. And you're right. So there's this very classic quote from Ben Trainer-Sloss, who runs the global SRE team and practice at Google. So the key realization that Ben had is that 100% is essentially the wrong reliability target for everything. And this is where error budgets come from. Firstly, it's not possible to have a 100% reliability target for our systems. If you do that, it's not realistic, right? You're chasing after a dream that's not going to happen for several reasons. The cost far outweighs the effort that's needed, or the benefits you'll get from going towards 100% reliability. And also, very often the difference between even the 6 nines, 7 nines, for example, service to the consumer is not discernible as a difference to the consumer. Lastly, a lot of that reliability, that last mile, is out of our control. That unreliability could come from something that went wrong with the Wi-Fi network, with the user's phone. It's not something that you can control across the end of the spectrum. So what do we do instead of going for 100% reliability target then? We need to pick what is going to meet the needs of our users. Think about your critical customer user journeys. Are people going to notice that things are down? And that's the most important concern, which tends to be the domain of product management usually. Now then, the amount of unavailability you're willing to tolerate in your service is your error budget. And of course, you need to measure that. Once you know how much of your error budget you have left, you're able to choose how you're going to spend the error budget. For example, shipping new features or doing experiments. As a very quick and dirty example, imagine that in your error budget for the month, you have maybe an error budget of 10,000 bad requests left. So knowing that you can only afford to have another 10,000 bad requests in that month, you need to prioritize your development cycle, whether you want to spend more on pushing out releases that help achieve stability and reliability or monitoring, or you want to take the risk and push out new features, knowing that there's a possibility that the features might cause something to fail and eat up your error budget of bad allowable requests. So this is a very powerful concept because you now have an objective way to measure reliability rather than a gut feel or, hey, something went wrong because somebody raised a ticket. And whether or not you are meeting your agreed upon business goals. So now when you are measuring and enforcing your error budget, suddenly you will find that both the devs and the SREs are motivated to balance development velocity with reliability. Both sides are working together, and the devs are empowered to manage the risk themselves. Likewise, the SRE team knows what to focus on, improving reliability, or other things they also care about, which we'll look at later. So here's how we talk about error budgets. It boils down to 3 terms, essentially. SLIs, SLOs, and SLAs. Internally, sometimes we like to call them slice, slows, and slays, just for fun. The SLI is a measurement. It is a metric compared against a threshold, and it tells you at any moment in time when you look at it, whether your service level was acceptable or not. The SLO is the goal for the aggregate of the SLI over a window of time, and it is the mathematical bound of the error budget. It says, over this window of time, this is my target, and the amount by which I exceed the target is the remaining budget. So the SLA is mostly relevant to a business. It defines what you're willing to do, such as refunding money if you fail to meet your SLOs. So defining SLOs is a pretty complex topic. I can't really describe all the nuances involved in the time that we have. But the important thing to do is to come up with a simple SLO first. Just one will do. And then iterate on it over time. You can totally use a primitive metric to set priorities and then decide what you want to do afterwards. Now, some other things to think about surrounding this is when you do come up with your SLOs, how would you disseminate your SLO to the organization? Do you store in a document? Where is the SLO document stored? How do people view it? How do you know that the SLO you came up with matches your customer expectations? What is your SLO review process? Do you review it every month, every 6 months when you push out a major new release? How do you incorporate your SLOs into your system design process? How do you measure if you're compliant with your SLOs? These are some things that you need to think about. So, because of this, effective SLOs then require buy-in from business, development, and operations. They bridge all three of these domains and give them a common language, unlike pure Agile or pure DevOps. So tying it back to DevOps and our analogy, error budgets help us embrace failure as a normal facet of development. It allows us to share ownership of reliability across organizational roles and not just within the operations team, and also requires well-defined reliability measurements. If you can't measure it, you can't evaluate it, effectively it doesn't exist. So the concept of SLOs and error budgets are all good and well, but how do we actually defend them on a day-to-day basis? We need to work in a few key areas of practice within the SRE team. So these are some of the areas of practice that we usually tend to think about: metrics and monitoring, capacity planning, how do you handle change management? And as we said, things will go wrong. And when they do go wrong, how do you respond to emergencies? And culture. I talked earlier about measuring your SLOs, and this is where monitoring and alerting comes from. You need to measure how well you're doing against the targets that you have set. And you need to have high quality alerts that fire only when an error budget is threatened, so that people don't get pager fatigue. And finally, you need to be able to really dig in when an alert fires and figure out what's gone wrong. Capacity planning. Now, even if the cloud can scale infinitely, your CFO surely cares a lot about the cost of running and scaling a service. And so you need to plan for both what we call organic growth from new users signing up, for example, as well as inorganic growth from launches and new features that consume more resources. In order to plan effectively, you need to be able to mathematically correlate the capacity of a service to the resources consumed by it, be it through heuristics or some kind of back-of-the-envelope calculation, and not just through intuition. On the other side of capacity planning is efficiency and performance. And someone needs to own this part as well. Let's tie it back to SLOs for a moment. It doesn't make sense to have your service run super duper fast, because if you're over-provisioned by a factor of 10, then you're wasting 90% of your resources. On the flip side, it also doesn't make sense to run a service at only 99% utilization, because you might have your latency degrade and have all your users unhappy, and to be burning up your error budget. So you have to strive for something in between. You can do this by detecting when your error budget is being threatened and adjusting capacity accordingly. Or even better, by detecting that a new release is causing those problems and roll back that release quickly rather than throwing more resources at it. At Google, we have found that 70% of outages are caused by changes made to a live system, whether that's a new binary or a new configuration that's being pushed. And we are constantly making changes to our systems. We push to production hundreds, thousands of times a day. So how do we manage that risk? Well, we try very hard to avoid making global changes and instead progressively roll out changes over hours, days, or even weeks. So, if we are using a bunch of Google apps on a phone, you might notice that some apps now have dark mode, right? So that's an example of this in practice. Dark mode doesn't come to everyone immediately. It's a progressive rollout. We have good monitoring. We want to have a low mean time to detection. And also low MTTR. We want to make it very easy and very safe to do rollbacks at any time. Now, those are best practices, and we work a lot to automate these practices and to remove the human element out of this. So good change management is about pursuing maximum change velocity. In other words, it's about trying to make all software releases a routine process or a standard change. ITIL terminology for those who grok, that kind of stuff, until we exhaust the error budget, and then we need to slow down a little bit. And then at the intersection of change management and capacity planning, you have provisioning, which is about quickly and safely changing the size of an existing service, either by adding additional instances, or locations, or removing them. Depending on the change, it can be a fairly complex process. And if you have a fairly complex process, it means that it is going to be a risky process, which requires careful change management, preferably through automation. The more complex and risky it is, the more we want to remove the human element out of it. Now, the fourth key area of practice in SREs is dealing with incidents. What happens when things do eventually break, and they will break? For many people, this is a fairly stressful time. So it is important to have well-defined processes, and even more important to practice these so that when you are facing a real incident, you don't panic and focus on what matters, restoring the service to a healthy state by mitigating the issue. Now, once that's done, you can work on the longer-term work of troubleshooting and fixing the actual problem so that it will not happen again. It really is a collaborative and a team effort, and the larger the incident, the more people need to pull in SREs and devs. So some of the things that I've seen SRE teams like to do is that they conduct sort of role-playing scenarios. So once every week, it could be like a lunch and learn, or on a Friday evening, they get some beers, some drinks, some food, and then they gather around a table, and then they replay a past production incident that has happened. So they simulate that scenario, and they ask the SRE team, look, so this is a scenario that happened in production. How are you going to deal with it? How are you going to troubleshoot it? So it keeps the skills of the SRE team sharp, and it also serves as a good way of sort of getting new hires up to speed, right? Rather than looking through a bunch of documentation, they get to immerse themselves in sort of like a real simulated production outage and see what they can do to address that. And the thing about all this stuff is the more you do it, the more routine it becomes. And when an emergency does happen, it becomes instinct. You snap into action and you're not, so I wouldn't say you're not, you are less flustered. And that's very helpful. So one of the most common failure modes that I see is that people don't pull in help when they need it. Often they are so caught up in the incident that they don't even realize that they need help. And that's where some of the role-playing I talked about previously, it comes into play. As I just said, emergency response is about having well-defined processes, and incident thresholds are an important part of that. When are you going to declare an incident and bring in other responders to help? This typically is about how much damage you have done to your SLO, how much of an error budget you have consumed. So for example, say if you're on track to exhaust your entire error budget for the quarter in the next few days, or even the next few hours, you probably want to declare a production incident. On the other hand, if you have it under control and your error budget isn't at risk, maybe you can spend a few more hours to look at what's happening on your own without pulling in other teams. Now, defining ahead of time the thresholds for what constitutes an incident and how and when to escalate problems, sets expectations, and lifts those concerns off the shoulders of responders. It's essentially less stress for the people who are responding to that situation. Now, define these thresholds ahead of time so that when things do go wrong, people don't have to worry or wonder about whether or not to declare an incident and who to call in. So after the emergency has been mitigated, your focus is really on preventing the problem from happening again, making sure you have really figured out and understood the primary causes, and are planning work to improve the reliability of your service accordingly. That is, you are planning not only the work that will prevent a recurrence of this sort of failure, but also work to address any other issues you have uncovered that contributed to the severity and scope of the incident, as well as limiting the impact of this class of failures in the future, thus making it easier to recover quickly the next time such an issue is detected. So finally, the very important and critical characteristic of postmortems is that of blamelessness. Now, humans are never the cause of incidents. Remember that we treat operations as a software engineering problem. And so when things do go wrong, we look for the flaws in the system that allowed things to go wrong. And we look to improve things to help reduce the opportunity for human errors and limit their impact and blast radius. If you really want to learn all that you can from an incident, you need to be able to get to the bottom of things, and you can't do that if people are scared. Everyone makes mistakes. That's not the problem. The problem is when our systems allow these mistakes to be damaging. So the last key area of SRE, we like to think of it as a cultural one. It is the ability for SREs to regulate their operational workload. We define operational work or toil as tasks that are required to run the service, which are manual, repetitive, automatable, tactical, and lack enduring value, or it could be just that it scales linearly with service growth. Now, operational work is important. If you don't do operational work, you won't know what to automate, right? It gives you the experience you need to improve your service and design better systems. Of course, you can't automate everything, and there's always more stuff to work on. But if all you do is operational work, you're no longer an SRE. So in Google, we enforce a strict policy of capping the amount of operational work for SREs at 50% of one's time. I've said previously that SRE is about treating operations as a software engineering problem, and that it calls for hiring people with software engineering skills. What we have found works best is to have a mix of both software and systems engineers. Each of these groups brings a different but needed perspective to the role. Some people straddle the line between the two, but many don't, and that's okay. What we need is a balance between the two. Finally, empowering SREs in the organization is critical. They need to be able to say, you know what? Our error budget is in danger. We need to spend more time on reliability and push back on new feature releases. It's hard to get the right mix of skills on an SRE team, and so you don't want to burn them out by burying them in operational tasks and toil. Instead, you want to help them find the valuable work that will help them in their careers and deliver value for the business. So these 5 areas that we have talked about are the key practices for implementing SRE, but you can apply them within a team that's supporting a service, even without having a separate SRE team. We have found these practices to be really valuable in supporting these engineers and providing a structure of expectations to make sure that they're rewarded for this kind of work. So tying it back to our earlier DevOps analogy, we've added blameless postmortems, automation, and monitoring of toil to our list of practices. So, how to get started? I recommend that you do these 4 things. Define an SLO, one SLO. If you don't have a measure of reliability, if you have no idea how reliable your service is, if you can't quantify it, you can't start at all. Right? It's okay to start simply. You need to hire people on your operations team who write software or upskill people on that team. It's not an either-or thing, you can do both. Foster support and respect for the work across the entire organization, not only within the operations team, where they need to acknowledge and be enthusiastic about automation, but also across the development and product management roles, where they have to acknowledge the error budget and its consequences. They have to have complete buy-in into the error budget. Finally, you have to have that feedback loop for self-regulation. You need to have people who can pick their work and empower them to push back and say, you know what, we can't really support this new product right now because we're overwhelmed with what we already have. It is possible for everyone to do this. So sometimes I get people coming up to me and saying that, hey, you know, we are not a digital native, we are not a tech company, we are a traditional enterprise, we are a brick and mortar company, we can't do that. But we have seen SRE practices being implemented successfully across many different industries, many companies. We have seen it being implemented and rolled out within banks, retailers, airline companies, just to name a few. Some of these have been around for years and years and years and have been running monoliths even before they transited to microservices. And they've all managed to successfully, well, not quickly, but successfully implement SRE practices within their org. So start small and let it grow. Pick just one service to begin with. Make sure that that team has strong executive sponsorship and support. Foster the right culture. Measure everything, measure reliability, track the amount of toil that your team is doing, and don't expect immediate perfection. Just improve over time. So we believe that SRE is an effective way to be reliable in the cloud, and that we think of these 2 arguments that matter the most. The first one is the idea that effortless scaling cannot mean a proportional increase in the number of people working on operations, or their team will get buried in operations. If you focus on prioritizing for operability and reliability, your services can run better without needing more people. The other thing that's important to highlight is that product development and operations don't have to be in opposition with each other. If instead you have the ability to agree on whether the system is reliable enough, and then choose accordingly whether to invest in more features or more reliability. Making that decision at any point through mutual agreement rather than tug of war. And you're able to do that because you have that mutual vocabulary, mutual agreement through the error budget and the SLOs that are defined in conjunction with product management. So let's quickly look at some ways that you can get help. So some of the assistance can be provided through, we have a professional services offering, which does SRE Fundamentals and training to develop SLOs. And so we have a bunch of books that have been written by Googlers and some other folks on SRE. The first 2 books are available freely online, so please check that out. They contain a lot of useful information. And in the second one, you can also find case studies of how some enterprises have transited from a traditional operations model to a SRE approach. Evernote and Home Depot being 2 of them. And with that, thank you very much.